Hey guys, this is Mrs. Rajewski. Welcome back. Today we are going to move forward and we're going to do some matrix operations. But first, let's get our brains warmed up. So here we go. Go ahead and fill out this warm up, see how well you can do. Go ahead, pause it, and get started on that warm up. All right, so now that you've tried the problems, what number is in row 1, column 2? Hopefully you said that this was row 1, and if this is our second column, then we must be looking at 1. So let's put a 1 right here. What number's in row 3, column 3? Well, we'll go down to the third row, and we are in the third column here, so that's going to be 6. What's in row 2, column 1? Well, I'm here in row 2. I'm going to stick around in the first column. That's number 3. What number's in row 2, column 4? So I'm in the second row. I'm in the fourth column. That's a 0. And lastly, what's the number that's in row 4, column 2? Well, here I am, row 1, row 2, row 3. Oh, no. There is no row 4. So that's just nothing. There's nothing there. It was a little bit of a trick question. I won't do that to you too much. But there's nothing. Nothing is in row 4, column 2. Don't put a 0 because a 0 is something. It represents nothing, but it's still something. And then, a little blast from the past, little vector operations here. So they're supposed to calculate the dot product. So if I want to know the what vector A is, I can write it in component form. That's my favorite way. So vector A is simply my horizontal component, which is -6. And then my vertical component, so I'm going up 8. And vector B is a little different. This one, my vertical component is 5. It's going in the positive direction, so that's going to be a positive 5. And its vertical component is 12, so that will be 12. All right, well, that's not the dot product. That's just the vectors in component form. But I like writing the vectors in component form because it's easy to calculate the dot product from there. So we're just going to multiply together our horizontal components. Those are the first numbers we wrote down. So I'll multiply together -6 and 5. And then I'm going to add the product of the vertical components. So that's going to be 8 and 12. All right, let's get to multiplying. -6 times 5 is -30. And 8 times 12 is 96. And 30 plus 96 is 66. This is our dot product. Perfection. And I like to sometimes hide my solution underneath the boxes. So yay, we got it right. Woohoo! Let's move along. Today we are going to talk about matrix algebra. So welcome to the matrix. No one can be told what the matrix is. They have to see it for themselves. The great words of Lawrence Fishburne. Did you guys love that movie? I totally did. So sometimes students will look at a matrix at first and say like, whoa, this looks crazy. But don't worry, it's really not. You can follow along in our textbook in section 7.2. It's actually really fun. I love matrices. So here we go. Section 7.2 starts on page 577 in our text. Hopefully by the end of today's lesson, you're going to be able to find sums, differences, and the products of matrices. So here we go. Let's start off by defining what a matrix is. If we have an M by N matrix, it's basically telling you how many rows and columns that there are. So we'll let M be the number of rows and N would be the number of columns. So what we see here is a matrix that has some number of rows and then some number of columns. I was just teaching my daughter how to do some beginnings of multiplication, and I wrote this so that she would remember what a row was and what a column looks like. Maybe that will help you too. So in notation, we're using what we call a double subscript notation. So you'll see this A and then subscript IJ. I represents the row and J represents the column. So if we look up here, this A sub 1, 2, this is telling me that it is in row 1, column 2. And you can see that, right? It's in row 1 and also in column 2. So that's what that subscript notation is telling you. It's just like where its location is. Then we have the element. The element is the actual thing that's in the matrix, that item that's in the matrix. So our element is whatever that number is. A row vector is simply a fancy name for a matrix with a single row, and a column vector is a matrix that has a single column. So now we get to our first example. So our question asks us to find the order of the matrix and then to identify some of the elements. Well, that's cool. The order of a matrix is the number of rows times the number of columns. Now, it's not an actual product, like a result. You're not going to do the multiplication. You're just going to write it almost like dimensions. So let's start off with the number of rows. In this case, we've got 2 rows. So our order is a 2, because that's the number of rows, by, and then I need the number of columns. Well, I've got 3 columns. So the order of this matrix is a 2 by 3. This is a 2 by 3 matrix. Please don't say 6. Please don't. Don't let that be you, okay? This is a 2 by 3 matrix, please. All right, so let's go on and identify some of these elements. Here I've got A sub 1, 2. So this is telling me to find the number that's in row 1, column 2. So the first number is always going to tell you which row it's in, and the second number will always tell you what column that it's in. So A sub 1, 2 is the piece that's in row 1, column 2. So here I am in row 1, and column 2 is this column. So it looks like we must be -2. Now, I've switched the numbers a bit. Tricky Mrs. Rajewski. So I've got my element that's in row 2, column 1. Can you see it? Here we are in row 2, and then column 1 is this element right here. So that's got to be 2. Perfection. This goes along with problems 1 through 10 in the textbook if you're doing your homework there. So why don't you guys try this one on your own? Go ahead, pause it, and see if you can figure this one out. Did you pause it? Okay, here we go. Let's solve it. First, we need to find the order of the matrix. In this one, we've got 1, 2, 3, 4 rows. So this is a 4 by, and now we need to count the columns. 1, 2. So this is a 4 by 2 matrix. Easy peasy. Now we're looking for some of these elements. So I'm looking for the number that's in row 2, column 2. So row 2, and then column 2, that's going to give me 4. And this element is asking me for row 4, column 3. Well, I know I don't have a third column here, so this is nothing, or you could write none, impossible, doesn't exist. And let's move on with our lives. So let's go on to something that's a little bit more useful, perhaps. Matrix addition and subtraction. So just like fractions or monomials, matrices are very picky when it comes to the operations of addition and subtraction. They're not going to just add or subtract with anybody. So let's take this matrix here. This one is a 3 by 2 matrix. And of these following 3 matrices, there's only one that it's going to add and subtract with. Which one do you think that it would be? Why? Do you think you could add it with this? Will this create a whole new column in the matrix? Or perhaps we can, just add it off to the side and give it like a funny shape. I don't know. In fact, the only way that you can add and subtract matrices is if their orders are the same. So where this is actually a 3 by 2 matrix, it will only ever add or subtract with another 3 by 2 matrix. Do you see which one? Yep, it's going to have to be this guy. And it's the only one that is also a 3 by 2 matrix. So these can be added and they can also be subtracted. What do you think the result would be? Let's just do the addition one. If we were going to add these together, what result do you think would come up? How do you think we'd be able to add this together? In fact, with matrix addition and subtraction, I would bet that your guess was correct. You're just going to add the corresponding elements together. So -2 plus 0 is -2. 0 plus 0 is 0. 8 plus 7 is 15. 3 plus 1 is 4. -1 plus 9 is 8. And 5 plus -6 is -1. This is the sum of our two matrices. And subtraction will work the same way. Isn't that cool? I know you guys can do this. So for our second example, we're asked to find the addition of these two matrices, the subtraction of these two matrices, and let's get crazy. We'll multiply one of them by 3. So here we go. We'll start with A plus B. So here's matrix A and here's matrix B. These are both 3 by 3 matrices. Because they have the same order, we can add them together. So let's move on to step 2. We're just going to combine the corresponding elements with the proper operation. So I'm going to do A plus B first. That was the first question we were asked to do. So that's the one we're going to do. So I'm just going to take the corresponding elements and combine them together. So that means the piece that's in row 1, column 1, I'm going to add that with the piece in matrix B that's in row 1, column 1. So I've got -1 plus 2. And let's go all the way down this column. So I'll do 4 plus -1. 2 plus 4. Now let's start with the second column. So we'll add together our second column. So I've got 0 and 1. 1 plus 0. And 0 plus -3. And now we can combine together our third column. So that is going to be 2 plus 0. -1 plus 2. And 1 plus -1. And we'll go ahead and get our final answer here. I've got -1 plus 2, which is 1. 4 plus -1, which is 3. 2 plus 4, which is 6. 0 plus 1, which is 1. 1 plus 0 is 1. 0 and -3 makes -3. 2 plus 0 is 2. -1 plus 2 is 1. And 1 plus -1 is 0. This is the result of A plus B. So now we're going to go ahead and we're going to do the same thing, but we are going to do the subtraction. So I'm going to just take a snapshot of this and hold it to the side for a moment. Oh my, that is not what I meant to do. I'm just going to hold that onto the side for a minute. And now let's try the subtraction. Sorry about that. Here we go. So let's try A minus B. Okay, so A minus B, it's very similar to A plus B, only instead of adding, we're going to subtract. So I'm going to still work with those corresponding components. So I'm going to take -1, which is in row 1, column 1, and I'm going to subtract 2, which is also in row 1, column 1. And I'm going to do it all the way down the column. So now I have 4 minus -1 and 2 minus 4. Now I'm going to take that middle column. So I've got 0 minus 1, 1 minus 0, and 0 minus -3. And now I'm going to subtract the third columns. So I've got 2 minus 0, -1 minus 2, and 1 minus -1. And let's see, -1 minus 2 is -3. 4 minus -1 is 5. 2 minus 4 is -2. 0 minus 1 is -1. And we have 1 minus 0. That's easy. 0 minus -3, a little addition. 2 minus 0 is 2. -1 minus 2 is -3. And 1 minus -1 is 2. And here we have our subtraction, our result from our subtraction. Very nice. All right, so I'm going to also take a snapshot of this and save it. Fantastic. And now we will find 3 times A. Let's see what we get. What would you guess that we would do to get 3 times matrix A? Because I bet what you think it would be is what it actually will be. In order to find 3 times A, all we're going to do is multiply every single element in the whole darn thing by, you guessed it, 3. So here we go. I'm going to have 3 times -1, 3 times 4, 3 times 2. That's the whole first column. Now for the second column, 3 times 0, 3 times 1, and 3 times 0. Now for the third column, 3 times 2, 3 times -1, and 3 times 1. Do your multiplication and we'll get 3A. Here we go. 3 times -1 is -3. 3 times 4 is 12. 3 times 2 is 6. 3 times 0 is 0. We've got 3 and 0 and 6 and -3 and +3. No joke, I actually really enjoy multiplying by a scalar like this. I think it's pretty fun. So hopefully you understood that. I know I showed probably way too much work on it, but I just wanted to make sure that there weren't any questions and that you could fully see where all these numbers were coming from. So let's move on. Ooh, this one's for you. Go ahead and take a minute to try this one on your own, and then let's see what you get. Oh, boom. I got my solution here. Did you guys try it? All right, let's see. What did you get? Did you get 5, 11, 11 for your top row? You should have, because 3 plus 2 is 5, 6 plus 5 is 11, and 7 plus 4 is 11. Did you get 2, 2, -3 for your second row? You should have, because 0 plus 2 is 2, 2 plus 0 is also 2, and 3 plus -6 is negative 3. And then for our final row, did you get 2, 3, 3? You should have, because 0 plus 2 is 2, negative 4 plus 7 is 3, and 2 plus 1 is also 3. I bet you guys got that one right. So let's move on. Let's talk about matrix multiplication. So in like the most strictest of senses, the matrix product of two matrices is also a matrix, and the elements of that matrix are formed by the sums of the products of the elements of the row of the first matrix and the column of the second matrix. That sounded crazy coming out of my mouth, and I'm sure it also sounded crazy coming into your ears. It's not intuitive, I will say. So just if you thought the addition and subtraction was great because it was what you guessed it would be, we probably wouldn't have just guessed how to do the multiplication. But all that being said, it's not too bad. So let's start with a simple row and column matrix. So I've got my row matrix and my column matrix. And I'm going to multiply these two matrices together. So how you do this is kind of fun, I think. You're going to take the first element of your of the first row in your matrix, and you're going to multiply that by the first element in the first column of your matrix. So we've got 5 times 4. Do you see that? Then we're going to multiply the second element in our row times the second element in our column. So that's going to be 2 times negative 3. So that's where we get this right here. And then we're going to take the third element in our row times the third element in our column. And that's the 1 times 6. So we take these products and then we just add them together. So 5 times 4 is 20. 2 times negative 3 is negative 6. 1 times positive 6 is positive 6. When we add these all up together, we get 20. This is it is a matrix. It's a 1 by 1 matrix, but it's a matrix nonetheless. So I do not want you to freak out when you see example 3, okay? Here we are going to multiply these two matrices together. Now, it is important to note, this one is already completely worked out for you. So it's kind of showing you what your work should look like as you're working through this process. So it's already worked out. Remember how I said that in order to add or subtract matrices, they had to have the same order? That is not the case when you're multiplying matrices, but they do have to have something in common. If we're going to multiply matrices together, the columns of the first matrix have to be the same number as the number of rows in the second. So here's what I do. I look at our first matrix and I say, oh, this is a 2 by 2 matrix, right? Then I look at this one. This is a 2 by 2 matrix. What step number 1 is saying is that this number and this number have to be the same in order for these matrices to be able to multiply. If those numbers are the same, awesome, you're going to be able to multiply these matrices. Also, it tells you what the resultant matrix is going to look like, because what's left over on the outside tells you the rows and columns of the answer you'll get. So the answer that I'll get from multiplying two 2 by 2 matrices together is going to also be a 2 by 2 matrix. Okay, so let's explain. Let's go through this one. It's already, all the work is already shown. I'm just going to show you how to generate it. Okay, so to create our first element, we are going to multiply the first row times the first column. So multiply element by element. The first row, first column, times the first row, first column. So this is going to be 1 times 3. Then you add the second element. 5 times the second element, 1. And 1 times 3 plus 5 times 1 is 8. Do you see that? Okay, so when you multiply the first row by the first column, you're going to get the first element. First row, first column. That's what we multiply together, and that's where our result goes. It's in the first row, first column. So now we're going to find the second element. The second element is in my first row, but it's in the second column, right? So this tells me what I'm going to be multiplying. I'm going to multiply the first row times the second column. Here we go. Element 1 times element 1. So that's going to be 1 times 4 plus my next element, second element, 5 times the second element, 6. 1 times 4 is 4. 5 times 6 is 30, and 4 plus 30 is 34. We've got our second element. If you're ever not sure what things you need to multiply together, try and think, what position am I trying to find? This number is in its element in row 2, but it's in column 1. So that tells me that I'm going to multiply the second row times the first column. And we multiply these corresponding elements together. So my first element is 2. My first element is 3. I'm going to multiply 2 times 3. Now let's see. I'm going to multiply my second elements. 2 times 1. So 2 times 3 is 6. 2 times 1 is 2, and 6 plus 2 is 8. We've got our third element. So now let's find our fourth element. The position the fourth element is in the second row. It's also in the second column. So that tells me what I need to multiply together. The second row and the second column. We're going to multiply together those corresponding components. So 2 times 4, because those are both the first components here, and 2 times 6. Those are both the second elements. 2 times 4 is 8, 2 times 6 is 12, and 8 plus 12 is 20. I hope that that wasn't too confusing. I hope it helped kind of having everything all worked out for you already. And your answer matrix is this matrix down here. It is in fact a 2 by 2 matrix, just as we predicted up at the beginning. All right, so let's try another one. This one isn't all worked out for you. We just got to do it ourselves, okay? First thing we got to check is, can we even multiply it? So let's look at the order of these matrices. This is a 2 by 3 matrix because it has 2 rows and 3 columns. This is a 3 by 2 matrix because it has 3 rows and 2 columns. Can I multiply these together? I absolutely can. I can because the number of columns in my first matrix is equal to the number of rows in my second matrix. But not only that, I can tell that my resultant matrix is going to be a 2 by 2. I'm going to actually use this to help me set up my answer or my work a little bit easier. So you don't have to set it up like this. I just like to. I know that I'm going to get a 2 by 2 matrix for my solution. So I'm just going to set up some work. Sorry guys, I'm still getting used to this pen. It's a little crooked. I'm going to try and set up this 2 by 2 matrix. So do you see the 2 by 2? It's got 2 rows and 2 columns. I know that's where my answers are going to go. So here we go. For my first element, I'm going to work with the first row and the first column. So my first row is 2, 1, negative 3. My first column is 1, 0, 1. I'm going to multiply the corresponding components together. So I'm going to have 2 times 1 plus 1 times 0 plus, negative 3 times 1. Maybe tidy that up a bit, huh? There we go. All right. And we can simplify it now if you like. 2 times 1 is 2, 1 times 0 is 0, and negative 3 times 1 is negative 3. 2 plus 0 minus 3 is negative 1. So my resultant matrix is going to have, AB, is going to have negative 1 as the first element in the matrix. So let's continue now. You know what? I'm just going to erase this one over here because we know now that they could be multiplied together. Here we go. So now I'm in the first row, but I'm in the second column. So I'm going to be multiplying the first row and the second column. So let's multiply those corresponding components. What I mean is if it's the first thing in this row, that I'm going to multiply it by the first thing in this column. So 2 times negative 4 plus, now I'm going to multiply the second pieces. 1 times 2, because this is the second piece in this column. And then negative 3 times that third piece, 0. Woohoo! All right, 2 times negative 4 is negative 8. 1 times 2 is positive 2. And negative 3 times 0 is 0. Negative 8 plus 2 plus 0, this is negative 6. So we've got our next component. Excellent. Let's move on. Now we're in this position right here. This is our second row, but it's our first column. So we are going to be working with the second row and the first column. So 0, that's my first element, times 1, that's the first element in my column, plus 1 times 0, those were my second elements. Now my third element's 2 times 1. Simplify it out. 0 times 1 is 0. 0 times 1 is, also 0. And then 2 times 1 is 2. That gives us 2. I've got my third element. Last one, here we go. This time I'm going to be multiplying because I'm trying to find this position. I'm trying to find the second row, the second column. So I'm going to use the second row and the second column here. Multiply the elements that are in each position. So 0, first position, times negative 4, first position, plus 1, second position, times 2, plus 2, third position, times 0. Oh my. 0 times negative 4 is 0. 1 times 2 is 2. And 2 times 0 is 0. All I've got here is 2. That completes my product. I'm done. Now, there's a song for this. What you say? I'll provide a link on the website, and I'm actually going to sing it for you. Are you ready? Here it goes. Row by column, multiply them line by line. Add the products, form the matrix. Now you're doing it just fine. This tells you how you're going to be multiplying these things together. Row by column, multiply them line by line. It's helping you remember what you're going to be multiplying. Add the products. That's what we did here. We added the products together. So when we multiplied them, then we added them. Form the matrix. I'm so sorry that I'm saying to you guys. So that was what we did down here. We formed the matrix. Now you're doing it just fine. Hopefully. That's what I hope. Moving on. All right. So this is one for you to try. Get a little bit more practice. So go ahead and pause it. See if you can figure this one out. Truly, it helps if you do this on your own. And then come back and we'll work it out together. Did you notice that this one was B times A and not A times B? Oh, so sneaky. So, of course, we want to check and see if we can even multiply them at all. This is a 2 by 3 matrix. And this is a 3 by 2 matrix. So absolutely so, we can multiply these together because this is, these guys match. And my result is going to be a 2 by 2 matrix. So let's go ahead and try that. So I've got, I'm going to set up my 2 by 2 matrix. 2 times, you know, if we're trying to find B times A, let's actually turn this around. So that we're looking at it in the proper order. Because if we were doing A times B, we could do 2 by 3 times 3 by 2. But I almost caught myself. This is asking us for B times A. So let's move it like this, B times A. Well, now we can see that, ooh, we don't have a 2 by 3 and a 3 by 2. We've got a 3 by 2 times a 2 by 3. And we can still multiply them together, which is fantastic, but I'm not going to have a 2 by 2 for my result. I'm going to have a 3 by 3 by result. Ah! Okay, so make sure you're really careful here because it almost got me too. So let's find BA. So I'm going to set this up not with a 2 by 2, but with a 3 by 3. You guys like to play tic-tac-toe? I hope so, because that's what we're doing. Wowzers. Here we go. Row by column. So row by column. 1 times 2 plus -4 times 0. Let's see. That's going to give me 2 plus 0, which is 2. All right. And next one. Row by column. So this is going to be 1 times 1 plus -4 times 1. So that's 1 minus 4, which is -3. And row by column. 1 times -3 plus -4 times 2. So that's going to give me -3 minus 8. Oh, good gravy. That'll be -11. All right, so we got that whole first row. I'm going to go ahead and just continue through and we'll write our answer at the end. So now we're in the second row. So I'm done with 1 and -4. I'm never going back there. So here I am with 0, 2. I'm going to be multiplying that through each of these columns. So 0 times 2 from my first column plus 2 times 0 from my first column. That's 0. Moving on. 0 times 1 from my second column, because I'm in the second column now, plus 2 times 1 from my second column. And that's just going to give me 2. And now for the third column, because I'm in the third column now, this is going to give me 0 times negative 3 plus 2 times 2. That's 4. Fantastic. Now we're on to our third row. I am done with 0, 2, never going back there. I am in this third row and I'm going to stay there till the end. Here we go. 1 times 2 from the first column plus 0 times 0 from the first column. That gives me 2. 1 times 1 from the second column plus 0 times 1 from the second column. That's 1. And then 1 times negative 3 from the third column plus 0 times 2 from the third column. And that gives me negative 3. So my final answer, we're going to do the calculator work next class. So my final answer is going to be BA is a 3 by 3 matrix that says 2, negative 3, negative 11, 0, 2, 4, and 2, 1, negative 3. Final answer. All right, this is it, the last one. Here we go. This one asks us to find BA or state that it is undefined. Well, I am not going to get caught like last time. I'm going to switch these guys around. I know it's not as easy to do on a piece of paper, but here we go. And I am going to start by seeing if I can even multiply them at all. So let's see. I've got a 2 by 2 matrix here. And here I have a 2 by 3 matrix. So it's rows by columns. So can I multiply these together? I absolutely can, because these guys match. And my resultant matrix is going to be a 2 by 3. What? We've been working with all these square matrices, and you're telling me that we can have a result that is a rectangle? Absolutely so, my friends. So let's go ahead and do that. B times A is going to give me a 2 by 3. That is 2 rows, 3 columns. I am just writing on a curve today. Okay, so I'll change my perspective a bit. So let's see, here we go. I'm going to take my row by column. Let's see. 3 times 2 plus negative 4 times 0. That's going to give me 6, because this is 0. Next, we've got same row, 3 times, but this time the second column, times 1 plus negative 4 times 1. Wow, my 4 looks terrible. Here we go. Sorry about that. And 3 plus negative 4 is negative 1. Next, we have 3 times negative 3 plus negative 4 times 2. So negative 3 times negative 3 is negative 9, and negative 4 times 2 is negative 8, and negative 9 and negative 8 makes negative 17. All right, now for down below, now I'm in the second row, so I'm going to multiply through there. I got 2 times 2, that's my first column, plus 1 times 0, that's also my first column. That's going to give me 4. 2 times 1, I'm now in the second column, multiplying the second column, plus 1 times 1, still second column, so that's 2 plus 1 is 3. And 2 times, I'm in the third column now, -3 plus 1 times 2. 2 times -3 is -6. -6 plus 2 is -4. All right, so BA is the matrix 6, -1, -17, 4, 3, -4. You might wonder, when is it going to be undefined? It'll be undefined if these guys in the middle don't match. So if I would have asked you for A times B, they would not have been defined. So because we wouldn't have been able to multiply them together. So that's it. That's what I've got for you. Good luck with your homework tonight. I hope that it made sense. If you get stuck, go back in, and I really suggest looking at the fully worked out solutions to help you there. But I know you guys are going to do great. Have a wonderful rest of your day. See you next time. Bye.